Hello once again, and now we're on to chapter 12. It's about global climate. What is climate? What does the word climate basically means? It means the average temperature and precipitation that a place gets and all the associated things that go along with that, such as, do you have a desert with lots of sand that gets very little rain and it's hot all the time? Or do you get rain every afternoon and it's big leaves and it's all green and there's trees everywhere and monkeys swinging from vines to vines? That's a tropical rainforest. That's basically what variations in climate can produce. Here's what we look at as far as what we look at when we talk about climates. We talk about microclimates, such as the side of a mountain having one climate, a mesoclimate, such as the Great Lakes region, and macroclimates, like the eastern part of the United States, or even parts of South America over the Amazon basin would be a macroclimate. There's the whole global climate. What is the average Earth temperature? And then there are the climate controls. And those typically talk about, when you talk about controlling climate, it has to do with the latitude. How far north and south are you of the equator? How much land and water is around you? Ocean currents. Do you have warm ocean currents like the Gulf Stream off the east coast or the Japanese current? Or do you have the upwelling Peruvian current along the Peruvian coast of South America that keeps things pretty cool along the east coast, even though you might be at the equator along South America? And then, of course, the prevailing winds. Are you in your westerlies or easterlies? Pressure cells. What's the predominant high pressure or low pressure? Like in the mid-latitudes or just north of the equator in Africa, it's North Africa is mainly under subsiding high pressure, and that dominates the region, and that's why it's so dry there. And then we have mountain barriers. And then, of course, the altitude over mountains and things like that all contribute to the climate of a specific area. Let's look a little bit closer here. Global temperatures, east-west isotherms. That's basically, if we look at the temperatures across the whole globe, you'll see that they're lined up east to west. And that's because as further north you go, the colder it gets, and the further south you go, the warmer it is towards the equator. And there's bends or kinks due to ocean currents and, of course, the continents. And global precipitation. Precipitation occurs consistently where low pressure belts exist in the global circulation model. And of course you have mountains that produce rainy sides, and then you have the rain shadows on the other side. Here's what we're looking at as far as those temperatures go. You have the cold temperatures up here to the north, and of course well to the south where we have Antarctica. And then in between at the equator, it's generally every afternoon it reaches the 80s. And over the tropical rainforest, it's quite moist in places like that, 60s and 70s. Mid-latitudes, the seasonal average temperature, like here in Pennsylvania, if we average it out for a whole year, is about 50 degrees, which isn't really that bad when you consider it. Some things we look at. This is a cross-section of climate averages and locations. We have the North Pole and the South Pole. You have the regions in between, around 60 degrees to 40 degrees north, is where we have the polar fronts, and the polar front in the South Pole, and that's basically where we have precipitation bands, storms, winter storms, thunderstorms, tornadoes, and all that stuff hangs out here. Then we get into the intertropical convergence zone. Every afternoon, pretty much, thunderstorms and showers producing quite a bit of rain. In between that, we get the subtropical highs, where we have a lot of sinking air going on, and that's basically the air current where it rises at the equator, comes back north, and starts to sink. Then that pushes up some warm air, and then you get sinking air basically over the poles as well. And then here's a little bit description down here of the annual average type of weather. All season it's wet. You get wet and summer and dry winter regions to the north and south of the equator. All season dry in the subtropical highs. Then dry summer, wet winter, things like that. All seasons wet along the polar front. So it varies quite a bit from where you live. Here's some cities we're looking at here. San Francisco, which is a latitude of 37 degrees north, there's quite a bit of variability in annual precipitation, and you notice how it spreads out over the year. Precipitation maximum is in the summer. Precipitation maximum in San Francisco is in the winter, and in Baltimore it's pretty well spread evenly, about 3 to 4 inches. Kansas City, May gets about 5 inches of rain, and again in September another bullseye of rain, and dry period in the winter. So just the opposite of San Francisco. Also, you notice the amounts vary quite a bit. San Francisco is very dry in the summertime, even though it's quite foggy and actually quite cool during the summer there. Here's a little closer look at when we talk about microclimates in the Pacific Northwest. Here's the Olympic Mountains. You have the prevailing wind. You have what's called the Hoh rainforest, and that's on the west side of the mountains. Prevailing winds bring in precipitation. Then you get on the downwind side of that in Port Townsend, only 18.5 inches of rain, and that's only 60, 70 miles away, and it's 134 inches in the whole rainforest. So that's a lot of water, but a huge difference over the region. Of course, you get up in the mountains, and there's quite a bit of glacier activity going on there too. And we go one more slide here. Climate classification. The ancient Greeks, tropical, temperate, and polar zone. And we talk about the Köppen system. We'll get a little bit more into detail of that. And then the Thorndike system, which relates precipitation in evaporation ratio, or the PE index. And it's basically potential evapotranspiration. That's a little bit more heady stuff. We won't worry about too much about that. But in the Köppen system, we look at certain areas that seem to rely on wind speed and direction, where the high and low pressure systems are, where the ocean currents prevail, and how we get warm oceans and cold ocean temperatures, and how that keeps things moderate. Why it's mild in Britain due to the Gulf Stream here coming up out of the Gulf of Mexico, and all the way up into Norway, actually, along the coast. You'll have 40s, and even Iceland, 40s and 50s during the winter sometimes, when you're much further north than, say, here in Minnesota, where it's much further south, but you'll get down to 20 or 30 below zero with plenty of time for ice fishing in the winters there. So quite a bit of variability going on. Global pattern climates, you have the tropical Morse climates, that's Group A. General characteristics, year-round warm temperatures, abundant rainfall, extended northwest and southward from the equator, about 15 to 25 degrees. Major types, tropical wet and dry climates. These are the subcategories, AF, AW, AM, things like that, just to be aware of. And where things lie, how we classify them. You can see that we're in the D's and E's up to the north, C's in the mid-latitudes, B's and A's in the tropical regions, and they're all classified here on the side. You basically look over this chart. And again, this is in your text on page 352, it should be anyhow. And then if we look at another one on page 353, we go to the other side of the planet. We have Russia, we have the mid-latitudes. H here, of course, is a huge desert, the Mongolian desert, all the way into parts of northern Iran and even into parts of Iraq and in Syria. So we've got quite a bit of variability across much of the different hemispheres as far as climate classification goes and where things are at. A world with many climates. That's basically the topic. Precipitation extremes, rainforest locations on windward side of mountains and things like that. That's where you have the heaviest rains. Then you have the driest locations, and they generally tend to be in actually some frigid and polar regions, like the South Pole is actually the driest place on the planet, with often less than an inch of precipitation. Of course, that always falls as snow. That's why it never melts there. The global pattern climate, general dry climates. Classification Group B, precipitation most of the year. Potential evaporation and transpiration exceed precipitation, though. So it generally tends to be a dry climate. Extent of subtropical deserts extend roughly 20 and 30 degrees north latitude and south latitude. And the middle latitudes often surrounded by mountains. And the major types are arid, BW, and the semi-arid, what we call BS. And again, these are the Köppen classification system. A highland climate group, that would Group A, decrease in temperature with elevation, and a vertical zonation as well, so it depends on how high up you are. Observation, here's something that's interesting. Deserts with clouds and drizzle can still be very dry. A desert that owes its existence in part to the proximity to the cold ocean along the east coast of Africa, and actually the east coast of South America as well. Those are actually the west coast of Africa. I get my directions mixed up here as I look at my maps, and the west coast of South America as well. You have some very cold ocean currents, and since you have cold air there, and also on the sides of mountains, it tends to be very dry. Dry spells and droughts, there's a difference. A drought is a period of abnormally dry weather that is extended, and then you have a dry spell, which is typically normal. Any seasonal dry period can be a dry spell. Again, back to our close classification system. Group D is general characteristics, warm to cool summers and cold winters. Winters are severe with snowstorms, blustery winds, and things like that, a lot like we get in the United States. Extent north or Canada, perhaps. Extent north of moist subtropical mid-latitude climates, and major types, humid continental with hot summers, humid continental with cool summers, and then, of course, you get the subpolar as well. Polar climates, you get Group E, general characteristics, year-round low temperatures, extent in northern coastal areas of North America and Eurasia, Greenland and Antarctica, major types of polar tundra and places like that, polar ice caps as well. Boy, I bet you can guess where this is at. It's a tropical place, that's for sure. And sure enough, we're looking across parts of Iquitos in, I believe that's Brazil. We're in the tropical rainforest. And it's going to be very wet there all year round, January through December, though there is a little bit of a dry period in what we would call the summer months or the middle months of June and July compared to the rest of the year. But you're going from 6 inches to 12 inches in the wettest time of the year, which is around April. Mean annual temperature is about 77 degrees. Here we're looking at Africa. This is where a place in Africa would look like in along the west coast. And this is Timbo, and you can see the mean annual temperature is about 74 degrees. But notice the variation of precipitation. We go from 14 inches in the wet season to literally none in January. That's when the ITCZ, this line, starts to go further south. And then we look at here the precipitation that is falling from this cloud pattern. We have what's called virga, and that's precipitation evaporating before it reaches the ground, which is typical of this region, which is a desert. And basically Phoenix, Arizona, you can see the annual temperature here shoots up in July to around 90 degrees. Notice the precipitation fairly equal all year, but less than 2 inches. And you actually may get a peak in August here in Phoenix due to the summer monsoon that starts to kick in. And sometimes that month can actually be quite wet with upwards, I've seen as much as 4 inches in August for extremes for Phoenix, the Phoenix area. This is more typical of the front range of the Rockies. Summertime, you get cumulus clouds over the Rocky Mountains. Annual precipitation is greatest in May and June, but notice the temperature extremes all the way up into the 70s and 80s during the summer, down around 30 degrees as we're average. And then we move on to another place. We're looking at Mobile. Quite a bit of precipitation all year round. Temperatures swing up to the 80s to around to 50 degrees during the winter months. And then another place we're looking at here, Port Hardy. You can see the winter months, especially in the fall, very wet, driest in the summer, and that's up into parts of southeastern Canada. As we move on here to other parts, San Francisco, Sacramento, similar places, though they're further inland. Great differences in temperature. San Francisco is pretty even between 50 and 60 degrees all year round, so rather cool, but hot in Sacramento during the summer, and also very dry. This is the California climate. This is chaparral, all this brown stuff. It gets dry during the summer, and it burns. It's got a pitch in it, and this is why you see all those wild summer wildfires over Southern California. The pitch actually causes the plants to burn, to pop out the seeds, to replant itself, and so it comes back nice and green, and a few years later it does all the same thing over again. And it's meant to do that. It's meant to take advantage of the Mediterranean, what we call the Mediterranean climate. Where is this? This would be in the northeastern part of the U.S. This is a deciduous forest in the fall. Looks like some good fishing there, I bet. And of course, we're looking around Winnipeg, and Des Moines would be somewhat similar to that, but Winnipeg especially would have that type of look at it. Looking at the precipitation there too, a little bit more precipitation in further south than you would get in Winnipeg, and of course quite a bit colder in the winter in Winnipeg, but still not that bad, up around 70 for an average temperature in the winter or in the summertime, and not much different in Des Moines, Iowa. And also comparing here, we move on to Fairbanks, Alaska. Quite a bit warmer in the summer, very cold in the winter, below zero. And annual precipitation is along that. And then we go to the north slope of Alaska, or that was a picture of actually around Fairbanks. And now we go to Barrow, the north slope of Alaska. Actually gets up around 30s and 40s during the summer, below zero, well below zero in the winter. Annual precipitation, very little, kind of a dry place. And we look at here kind of barren and looks very dry except for the streams. And of course this would be great salmon fishing in the early springtime year. And then you get the mountain effects as well. Variation in climate, you get tundra down to mixed chaparral and grasslands. This would be very common in Alaska. That's all we have to look at for climate now, and we'll be on with the next chapter. We're moving on to 14, or actually chapter 13 coming up.